fellow students, welcome back to Algebra 1B. Today we're going to talk about sketching a graph in vertex form. So today we'll be graphing a quadratic equation that'll look something like this. Y is equal to 3x plus 4 squared minus 2. Now, in order to graph that, we're going to use the general form of vertex form. Vertex form is y is equal to ax minus h squared plus k. Now, instead of just giving you the formula and telling you what numbers do what, I thought it would be better to demonstrate this a little bit more visually. So I'm going to step over here into Desmos, and I am going to graph the equation y equals x squared. And you'll remember from the previous lesson that this is called our parent function. Parent function meaning that it is the simplest version of the quadratic. So what we did in the last lesson was we added the a value, which is the leading coefficient, the number in front that gets multiplied by. So I'm going to put y equals x squared, and you'll see there's that blue one. I'm going to turn on projector mode just because I like the thicker lines better. So right now they're the same thing, but if I put another number in front like 2, you'll see that it stretches out vertically. It looks like horizontally it's getting skinnier, but vertically it's getting longer. And if I increase that number to 3 or 4 or 5 or 100, we see that it stretches more and more and more until it gets really skinny. Now, if I wanted to make it wider, I could stretch it by a fraction like 1/2, and that would make it wider, or 1/3, 4th, 5th, 6th, 100th would look like that. We also talked about how this number, if we make it negative, will reflect it across the x-axis, flipping it upside down. Now, what happens if I add a number to the outside of this? So if I had x squared plus 3, what would that do? Well, if I add 3, let's see right here, plus 3, I can see it takes the graph and it moves it straight up 3 units. So it takes all the points in place and just moves them up 3 units. What if I subtract? Well, we see it does the same thing, but it moves it down 3 units. So this one's pretty easy to see. If I add or subtract to this function, it's just going to move it up or down. So if I do -5, it goes down 5. If I do +5, it goes up 5. That's called a vertical translation by 5 units right there. So now, what if I add or subtract a number directly onto the x value right there? So this would be adding or subtracting to the input of the function. So that means I'm going to be changing the value of x before I square it instead of changing it after it gets squared. So if I add 3, I see that it moves to the left 3. Now this seems a little bit weird because you would think that adding 3 would move it to the right because it's positive, but in this case when it's on the inside of the parentheses, it moves it to the left. So what if I do -3? You see that subtracting 3 moves it to the right. So on the inside of the parentheses, when I add to the input before it gets squared, it moves the entire function horizontally. So now let me go ahead and I'm going to put the parent function back. And let's just see, what if I put -2 and then in parentheses I added 1, and then outside I subtracted 4. So I've done 4 different things to this graph right here. And I've turned off the visual so you can't see it, but I want you to just take a second and think. What are the things that happened to this graph? Well, first, the negative's going to flip it upside down. The 2 is going to stretch it out vertically. The 1 is going to move it to the left 1. And then the minus 4 is going to move it down 4. So if you can kind of picture where that would be, I'll go ahead and click this and reveal it. There it is. So you see, left 1, down 4, upside down, and stretched by 2. So let's go ahead and go back to our question over here. In fact, I'm going to move down here. I'm going to write out vertex form. And that is y is equal to ax minus h squared plus k. So, just labeling what these things are, the A is the vertical stretch. And then if it's ever negative, it will also be the reflection. The H is the horizontal shift. And I'm just going to put a little star right here because I have to remind myself that it does the opposite of what I would think. And then the K is the vertical shift. Okay, so if I'm not using a graphing calculator, if I'm graphing by hand, how can I graph using this? Let's go ahead and try that out. So let's graph y is equal to, let's start off with an easy one. X plus 3 squared plus 2. So, step 1, I'm going to draw the parent graph. And hopefully, by this point, you're really good at drawing the parent graph. 0, 0, 1, 1, 2, 4. Axis of symmetry means it's the same on both sides, so I can draw that. Okay, step 2 is going to be apply the vertical stretch. Now in this case, there is no vertical stretch here, so I can skip past that step and go on to step 3, which is apply the horizontal and vertical shifts. So in this case, this 3, that's a plus 3. The plus 3 right here means it's going to go to the left 3, and then the plus 2 means it's going to go up 2. So I'm going to start right here at the vertex, and I'm going to go left 1, 2, 3, and then up 1, 2. And then from the first point right here, 1, 1, I can go left 3 and up 2. And then from 2, 4, I can go left 3 and up 2. And then I can just mirror that right there. And then I can draw my parabola. And I'm all done. Okay, let's try one more that's a little bit more complicated. Let's try y is equal to -1/2 x minus 4 squared plus 3. Okay, so step 1, just like before, let's draw the parent graph. Here we go, nice and easy. Okay, step 2, I'm going to do the vertical stretch. And in this case, there is a vertical stretch. So this is just like the homework that you had in the previous unit. So this is 0, 0. 0 times -1/2 is still 0. So that means that's right there. 1, 1. The vertical component is 1. So I'm going to multiply that by -1/2, which would be -1/2. And that's right there. The next one is 2, 4. The vertical component is 4. 4 times -1/2 is -2, so that would be right there. Then I can use the axis of symmetry to see that it looks like that. Okay, and then step 3, the horizontal and the vertical shifts. This is going to go to the right 4, and then it's going to go up 3. So right 1, 2, 3, 4, 1, 2, 3. It's right there. Now this one's going to go right 4 and then up 3, and then this one's going to go right 4 and up 3, and then I can use the axis of symmetry, which is moved a little bit, and then this orange parabola right here is my final answer. And that is how you graph in Vertex form.